welcome back everybody. In this final section we talk about stream landforms. So how can you look at the surface of the earth and tell what a stream might have been doing in the past? First we're going to consider a meandering river, and as it meanders it creates all of these other features. We have bluffs on either side, we have, relatively speaking, the valley in the middle, which tells us where the floodplain begins and ends. We have natural levees on either side of the river, which prevent it from getting too wide. And as the river flows, we have places with more erosion, the so-called undercut banks, and point bars, where sediment is deposited. We also have these features called oxbow lakes. And how do these form? Well, now we'll start here. We have areas of erosion with the teeth and areas of deposition with the small circles. And for reasons it'll become clear if they're not clear intuitively, the outside edge of the river, the outside of the curve, tends to be the place where the river erodes, and the inside of the curve is places where sediment is deposited. Okay, so this is what the river looks like to begin with, and slowly, we have teeth on either side, it eats away at this area here, eroding more and more on the outside of these curves. Over time, the river moves upwards like this, so we've eaten away at this area in the middle. This continues until we've eaten all the way through all of this area in the middle, and everything over here is abandoned. So we have a relatively straight river section here, and we have this abandoned loop, the cutoff, otherwise known as an oxbow lake. And these are actually relatively common features. They come in all sorts of shapes and sizes. So we have our main river, and you can look around, you see some full oxbow lakes, you see some that are somewhat partial oxbow lakes. These would tell an observer about the history of the river over time. We know that at one point it was flowing through here, and that over time it has meandered now over to its current position. Likewise, if I showed you a river like this, which doesn't seem to have any large oxbow lakes, and I told you to predict how it's going to change in the future, well, you would look at an area like this and say probably this is going to be a cutoff here, an oxbow lake in the future. You would look at an area like this. This could also potentially be cut off, a few different cutoff points here, and something like this definitely seems right to be cut off in the future. So now you have an idea of how the river is likely to change over time. Now, rivers, most of them also develop these sort of natural levee system, these sort of blockers on the edge of the river. So we imagine we have a river without these to begin with, and whenever it floods, it deposits sediment out to the side, everything that it's carrying. And the coarser sediments tend to be deposited close by. They don't get as far before they fall out. The finer, thinner, the less dense stuff tends to move a little bit further out. So then you have this natural buildup as it floods over time of these levees, which then prevent more flooding and stabilizes the system. So now, if I showed you an image like this of a river and these things, the natural levees, you could explain how these came to be, how they formed. So rivers erode on the outer edge of the stream and tend to deposit sediment on the inner point. And the result of this, you can see our yellow arrows here are the direction of channel migration, so it's going to eat away and move this way in our diagram, and slowly move this way as sediment is deposited here. These sediment buildup points are called point bars, and we would call this the eroding river bank. A lot of times as it erodes, it tends to fall in, and as a result of it slowly migrating left, you have this unusual shape for the river channel. It's not a perfect V. As a result of the unusual shape of it, you get what is called the helicoidal flow. In other words, in addition to this component of the river flowing down the page here, we also have some amount of flow within the river. So it's going to move a little bit faster wherever you have the shallower part of it here, and it's going to move a little slower wherever you have the longer, less steep leg of the river. Now, putting it all together, if I show you an image like this of a river, you could tell me what kind of a river it is and what makes you think that, as well as a couple of the characteristics associated with river. You could look at this image and point out, okay, where do we have erosion and where do we have deposition, and what is this thing called here, the point bar? You could do the same with this image, tell me where there is deposition, where there's erosion, what type of river, and maybe a little bit about how this river is likely to change over time, whether it is more likely to be a young river or an old river. Now, we also have these features called deltas. So we have our river system, finally it gets to the ocean, the big reservoir. And as it gets there, it dumps its sediment, And there's some that spreads out right away, and there's some that doesn't leave the river channel until it gets a little further. Slowly, over time, this is going to build up and out into sort of this bird's foot pattern, or sometimes more of a triangle pattern called the delta. And here's how you might apply this. Let's say that you were interested in looking at the history of the Mississippi River. Well, you would look and you notice that there's this delta, which is active now. You can tell because that's where the stream is, sort of the bird's foot pattern. But you could also look at these other things that seem to be deltas here and all in here, and there's a delta here and here and here. And you might be able to look at those sediments and look at the landscape and start to work backwards. And slowly what you would uncover is something like this, a breakdown of the ages of these different systems, and you could put together a more complete history for what the Mississippi River has been doing over the past maybe 10,000 years. Putting it all together here, what are the big ideas? You should know something about Earth's water percentages. You should be able to talk about our different types of stream channels, along with the characteristics, the stages, young to old, and the variables associated with each. You should know something about streams and rivers in Arizona and their behavior. And finally, you could talk a little bit about the stream landforms. That is all I have. For those of you who made it to the end, thank you.